Good afternoon, class. Today we are going on to the solution of exercise 7C of your E-Maths. Okay, I gave you question number 2. Note that these are 3D diagrams and you have to be very careful which triangles or which figure we are looking at. Okay, let's look at question number 2. The figure shows a rectangular box in which AB is 3, AD is 4, and BD is 5, and DH is 12 cm. Find the length of BH. Now everybody can see that BH is here, and I'm actually looking at this triangle, okay, DBH, and this is 90 degrees here. So if I were to redraw this triangle DBH, I will have this, and they say to find the length of BH, I just need to use Pythagoras Theorem. I get 13 cm. Okay. Next, in part 2, they want us to find the angle BDC. Now BDC will refer to this triangle that is at the bottom. Now if I redraw this triangle, I realize that this is 90 degrees. This is 3 cm, this is 4 cm, this is 5 cm. Now you can actually use any ratio. Sine, cosine or tangent also can, but I chose to use sine. So it's 4 over 5. I can get angle BDC as 53.1 degrees. Okay? Alright, last part, part 3, angle HBD. Angle HBD. Now, for angle HBD, we are still looking at this triangle, the big one here. Okay, so if I want to find this angle, I just apply tangent. I can find the angle as 67.4 degrees. So for 3D diagrams, it is not very difficult, but you have to ensure you know which you are looking at. Is it a vertical triangle? Is it a flat triangle? Is it on the ground? Okay, or is it slanting? All these are very important. Okay, so this is your question number 2. Now we move on to question number 5. Okay, let's take a look at question number 5. Okay, the question says, in the figure, the angle of elevation of the top of a vertical tower PQ from a point A is 30 degrees. Given that Q, the foot of the tower, is on the same horizontal plane as A and B, and that AB is 60 meters, angle BAQ is 45 degrees, angle ABQ is 75 degrees, find the height of the tower. Now, you have to look at this diagram carefully. This one is on the ground, whereas this one is the vertical one. Okay, so we have to be very careful what we are doing. Now, first, they want to find the height PQ. Now, I need to find the length AQ first. Now, let's look at this triangle. AQ over sine 75 is 60 over sine 60. I can find this as 60 by using angle sum of triangle. So I can find AQ as 66.921. Okay. Now, knowing that this is 66.921, I can find the height by looking at this triangle and applying tangent. Okay. So I will get PQ as 38.6 meters. This is by applying tangent. Okay. So bear in mind that this is on the ground, whereas this is a vertical plane. That means this is vertical height. Okay. Alright. So this is your question number 5. Next, we move on to question number 7. Okay, let's take a look at question number 7. Now, this is the diagram given to you. Okay, this is the diagram that is given to you. The question says, in the figure, ABPQ is the rectangular sloping surface of a desk with ABCD lying in a horizontal plane. Q and P lie vertically above D and C. Given all the information there, find the length of AC. Now I want to look at this whole diagram. AC is here. Okay. This is AC. So how am I going to find the length of AC over here? Now, let's take a look here. Okay. AC is this. Alright. Now, can you see that in order to find AC, okay, I need to know this length BC first. And I'm going to look at this particular triangle over here. This particular triangle over here. So I use cosine 25, I'll get BC over 75, I get BC as 67.973. Okay, then I look at the triangle that is lying on the floor, ABC. So I can use Pythagoras Theorem to find AC. So after I use Pythagoras Theorem and change it to 3 significant figure, I'll get 113 cm. Now bear in mind that triangle PBC is vertical, whereas triangle ABC is lying on the ground. We have to be very careful with what we are saying. Okay? Now part 2 says to find angle PAC. Now PAC is this angle here. Okay, PAC. Now first of all, I already found out what is AC. Okay, if I can find out what is PC, I'll be able to find this angle. Okay, now note that this particular triangle is also 90 degrees. I repeat, is also 90 degrees at this particular side here. Okay, if you look at triangle PAC is 90 degrees over here. Now I can apply Pythagoras Theorem. Okay, I can apply Pythagoras Theorem to find PC. So this, and this, it forms a right angle triangle. I can use Pythagoras Theorem. I'll get 31.696. Okay, now if you do not want to use Pythagoras Theorem, I can also use sine 25 as PC over 75 to get 31.696. So whether you apply Pythagoras Theorem or you apply sine, you can also get PC as the answer. We are referring to triangle PBC. Okay? Alright, now next, I'm going to try and find out what is angle PAC. Now, I already know AC. Okay, I'm looking at this triangle PAC, the vertical triangle PAC. I know that this length AC is this, and PC I found it in this part. So in order to find angle PAC, I just need to take tangent, and I can get the angle as 15.7 degrees. Okay, 15.7 degrees. Now for part 3, angle CAB. Angle CAB. Alright, note that CAB is a triangle that lies on the floor. So if I were to redraw this triangle on the floor, CAB, I'll get this as 90, this is 67.973, okay, and they want to find the angle CAB, I can use tangent, okay, and I will get the answer as 37.1 degrees respectively, okay. So for this type of question, we must be very careful which triangle we are looking at. Then we can get the answer easily, okay. Next, we are going on to question number 8. Let's look at question number 8. Okay, question number 8 states this. In the figure, a cuboid has a horizontal base EFGH, where HG is 15 cm and GF is 8 cm and BF is 7 cm. X is a point on AB such that XB is 4 cm. Find angle CEG. Now, if I want to find angle CEG, I'm actually looking at this particular triangle, the green one. Okay, and this is 90 degrees over here. So if I were to redraw CEG, I know that EG is 17 cm, because if you look at this triangle that is here, HFG, these two are the sides, this is the hypo, this is another right angle triangle. Okay, so EG square will be EG square, which is here, okay, this is 15, this is also 8 cm. So I will have EG square is equals to 8 square plus 15 square by Pythagoras Theorem. I'll get EG as 17 cm. So EG is 17 cm. That's how I get the 17 cm here. And don't forget, CG is also 7 cm. So in order to find angle CEG, I take tangent 7 over 17. I will get the answer as 22.4 degrees. 22.4 degrees. take note that we are looking at triangle CEG. Okay, and in order to find EG, I must look at this particular triangle that is on the floor. This is 90 degrees and this is the hypo. So 8 square plus 15 square must give you the hypo square. Okay, so that is your 8 part 1. 8 part 2, they want you to find angle GXF. Now for angle GXF, I'm looking at this particular triangle. Okay, note that X and F here, this particular angle here is actually 90 degrees because it lies in the same side, same face of the cuboid. ABFE, it lies on the same plane. So we have, I'm going to redraw GFX, it looks like that. Okay, now XF square is actually 4 square plus 7 square. How did I get this? Okay, how did I get this? Can you all look at this particular triangle here? Okay, this particular triangle is 90 degrees at B. Okay, it's 90 degrees at B. So if we look at this particular triangle, I can use Pythagoras Theorem to find XF. So it's 8.0622. Okay, then I look at this particular part, I already know XF, I know this as 8, I can find angle GXF. Okay, I want to find this angle, so I also use tangent in order to find the angle, and I will get the answer as 44.8 degrees. 44.8 degrees. Okay? Alright, that will be your example, your question number 8. Next, we move on to question number 11. Okay, question number 11. Alright, let's look at 11. The diagram looks like that. Okay, the figure shows 4 points O, A, B, C, which lie on level ground in a campsite. O is due north of A and B is due east of O. Given that OA is 28 and OB is 30, OC is 50 and BC is 70, find the bearing of A from B. Now, if I want to find the bearing of A from B, I must draw the north line at B. Okay? Now, I need to find this angle OAB, this particular angle here. I can find it as 46.974. Now, if this is 46.974, this will also be 46.974 because it's an alternate angle. They are alternate angles. Now, note that this is 180 degrees. So the bearing of A from B will be 180 plus this. I will get this answer, and we will give the answer to 1 decimal place. So it's 227.0 degrees. That will be question A part 1. Now, question A part 2, they want to find the angle COB. Angle COB, I can use cosine rule because I know this side, I know this side, I know this side, I want to find this angle. So I will apply cosine rule over here. Okay, apply cosine rule. Simplify it. Cosine angle COB is negative half. I will get COB as 120 degrees. Okay, now next part, part 3, the bearing of C from O. The bearing of C from O. Okay, now it will be the whole thing here. It will be the whole thing here. Now note that in part 2, I find that this whole angle is 120 degrees. Okay, if this whole angle is 120 degrees, now this will be 90 degrees. It follows that this will be 30 degrees because 90 plus 30 is 120. Okay, they want the bearing of C from O. That means I want this whole thing here. I want this whole angle here until here. So I take 360 degrees minus 30, I'll get a 330 degrees. Okay, 330 degrees. Okay, this will give us the answer to part 3. Now, the last part. A vertical flagpole stands at the point B such that the angles of elevation from O, A, and C are measured. Given that the greatest of these 3 angles of elevation is 29 degrees, calculate the height of the flagpole. Now, they have a flagpole that stands at B. Note that C is 70 meters from here. O is 30 meters from here. Now, this length here, you can use Pythagoras Theorem to find. Okay, you can find out this length, but knowing that this is the hypo, it must be more than 30 cm. So the length AB must be more than 30 meters. Okay, because it's the hypo of this right angle triangle. Now note that the angle of elevation will be the greatest if the distance from the flagpole is the shortest. So you can see this is 70, this is 30, this is more than 30. So the angle of elevation that's the greatest will be from O. Okay, at O here. So next, greatest angle of elevation occurs at O because it's the shortest distance from B. So let the height of the flagpole be X. Okay, so tangent 29, because we know that the angle of elevation is 29 degrees and this is 30 meters. I let the height here be X. So tangent 29 is X over 30. Then I will find the height of the flagpole as 16.6 meters. 16.6 meters. So let me reiterate this. The greatest angle of elevation will be at the point whereby it's the shortest length from B. Okay, the shortest length from B, which in this case here is at O. Okay, that will be your question number 11. Next, we move on to the last question. That is question number 13. Okay, question number 13. Alright, let's take a look at the question. What does it say? It says that a tree of height 24 meters stands vertically at A on the ground of an island. Two boats are at A and C such that, two boats are at B and C such that angle BAC is 94, angle ABC is 47, and AB is 240 meters. Part A, part 1. Find the distance between BC. Okay, we will have to use sine rule. Okay, we have to use sine rule. We can find this as 39 degrees because we use angle sum of triangle. BC over sine 94 is 240 over sine 39. I will get your BC as 380 meters. Okay, part 2. Find the area of triangle ABC. Now I already found this length, so I use half AB sine C to get the answer. Note that the final answer must be given to 3 significant figures. Okay, next. The shortest distance from A to BC. I've already explained this many times. The shortest distance from A to BC will be the perpendicular distance. Okay, now this is the perpendicular distance here. I call it AD. Okay, I call it AD. This is the perpendicular distance. Now I can use sine 47 as AD over 240. I'll find AD. So the shortest distance from A to BC is 176 meters. Okay, 176 meters. Alright? Okay, now, next, the last part. The boat at B sails in a straight line towards C. Find the greatest angle of depression of the boat from the top of the tree. Now, note that the greatest angle of depression will be equal to the greatest angle of elevation because if this is the angle of depression, this will be the angle of elevation, and they actually are alternate angles. Okay, so the greatest angle of depression will be formed when you have the greatest angle of elevation, and as I told you, the greatest angle of elevation can be, you can get it when it's the shortest distance from the tree. Okay. Alright, so I'm going to draw the diagram. I let the tree be 80 and it's 24 meters. So 80. Now, if this is going to be the greatest, this has also got to be the greatest. So it must be the shortest distance. So the shortest distance, I have to take this as the working, 175.52. I use tangent, I find theta. So the greatest angle of depression will be 7.8 degrees. Okay, note that the angle of depression is the same as the angle of elevation, and it will be 7.8 degrees. Okay, now for questions in 3D, we have to be careful whether we are looking at the vertical triangle or the horizontal triangle, okay, whether it's on the ground or it's upright, okay, that is above the ground. Okay, so you have to be very careful how the diagram looks like. Okay, that will conclude our exercise for exercise 7C on the 3D diagrams. Okay, thank you, class.